Hi to everyone, myself Dr. Dhananjay Rao, working as Assistant Professor in the Department of Chemistry. In previous video, I have explained about types of hardness of water, temporary hardness of water, permanent hardness of water, and different units for the hardness of water. Today, I am going to explain about estimation of hardness of water by using complex symmetric titration. Today in the class, I am going to explain about estimation of hardness of water by using complex symmetric titration method. See, we recall the previous video. What is temporary hardness? What is temporary hardness? Temporary hardness is nothing but it is due to the presence of calcium and magnesium bicarbonates. The water contains calcium and magnesium bicarbonates. Then the water is called temporary hardness of water. The temporary hardness can be removed by using simple boiling. Simple boiling, we can remove the temporary hardness. If water contains calcium bicarbonate, then if you heat, what happens? If you boil the calcium bicarbonate and magnesium bicarbonate containing water, that is called temporary hardness of water. If you boil the temporary hardness containing water, we can remove the temporary hardness from the water. See, if you heat the calcium bicarbonate, it converted into calcium carbonate and it releases carbon dioxide gas. Similarly, magnesium bicarbonate, if you heat, it forms magnesium hydroxide and releases carbon dioxide. In these two cases, the calcium carbonate and magnesium hydroxide, these both are precipitates. So, if you boil the calcium carbonate and bicarbonates in water, then it forms calcium carbonate and magnesium carbonate. These are the precipitate. So, by simple filtration, we can remove this precipitate from the water. So, in this way, we can remove the temporary hardness from the water. What is permanent hardness? Permanent hardness is nothing but the water contain other salts except these calcium bicarbonates and magnesium bicarbonates. If contain, that water is called permanent hardness of water. What is permanent hardness of water? The water which contains calcium and magnesium salts except calcium and magnesium bicarbonate. That water is called permanent hardness of water. By simple boil, we can't remove the permanent hardness from the water. By simple boiling, we can remove the temporary hardness, but permanent hardness can't be removed by the simple boiling method. See, in this method, we can estimate the calcium and magnesium salts are total hardness of water and temporary hardness of water, permanent hardness of water by using complex symmetric titration method. ETA, complex symmetric titration. What is nothing but ETA? ETA nothing but ethylene. ETA nothing but EDTA, nothing but ethylene diamine tetraestic acid. The structure of ethylene diamine tetraestic acid is this one. This is ethylene diamine. Diamine means 2 amines and tetraestic acid means it contains 4 acidic groups. CH2COH, CH2COH and CH2COH and CH2COH. 4 acetic acid groups. But in this titration, we don't use this pure form of ethylene diamine tetraestic acid. Instead of this one, we use disodium salt of ethylene diamine tetraestic acid. Why? If you take the pure form of ethylene diamine tetraestic acid, this is not soluble in the water. So, we can't prepare the standard solution by using this ethylene diamine tetraestic acid. So, for solubility reason, you have to go for disodium salt of ethylene diamine tetraestic acid. It is very soluble in water. So, instead of pure form of ethylene diamine tetraestic acid, we use disodium ethylene diamine tetraestic acid for the titration of ETA complex symmetric titration method. This disodium salt of ethylene diamine tetraestic acid is hexadentate ligand. Hexadentate ligand means it donates it contains 6 donor atoms for the complex formation. See, this is the one donor atom nitrogen. Here lone pair is there. Here lone pair is there. It is one donor atom. And this COO minus and this COO minus and this COO minus and this 4 COO minus ions are there. So, it contains completely 6 donor atoms. So, the disodium salt of ethylene diamine tetraestic acid is hexadentate ligand. The indicator is here is EBT. EBT nothing but areochrome black tea. This is the indicator we use in this process. This is the structure of EBT indicator. And we have to maintain the pH 9 to 10 in this complex symmetric titration. ETA complex titration method, we have to maintain pH 9 to 10. For that, we have to prepare basic buffer. The basic buffer prepared by this ammonium hydroxide and ammonium chloride. This composition gives the ammonical buffer is to maintain pH 9 to 10 throughout the reaction titration. Okay, this is the EDTA complexometric titration. These are the chemicals required in this EDTA complexometric titration method. See, what is the principle involved in this? We will go further. The Ca plus 2 and magnesium plus 2 ion present in water are responsible for hardness. What is hardness of water? The water which contains calcium and magnesium salts. That is called hardness of water. The hardness of water may be temporary or permanent. Okay, any. These ions form suitable complexes with indicator EBT, and these metal ions forms stable complexes with ETA. If you take total hardness containing water, okay, hardness containing water means the water contain calcium and magnesium salts, maybe bicarbonates or carbonates, chlorates, nitrates, whatever may be. Okay, the water contain calcium and magnesium salts. If for that, the water containing hardness water means the sample water contain metal ions. What are metals? Calcium and magnesium ions. Okay, these containing water, these ions containing water, when we added EBT indicator, if you add EBT indicator to that hardness containing water, it forms the water containing calcium and magnesium ions. So these calcium and magnesium ions, these forms complex with EBT indicator. Okay, these ions present in water means calcium and magnesium ions present in water, that those forms complex with EBT indicator. It forms metal indicator weak complex. The complex between the calcium and magnesium salts and EBT indicator is weak complex. Okay, the color of this weak complex is red color. Okay, the complex of the color is wine red color. See, this is the color of calcium and magnesium EBT indicator complex. If you add EDTA, if you titrate it with EDTA, what happens? The indicator is releases from metal, because this is the very weak complex, unstable complex found between metal and indicator. So if you titrate with EDTA, what happens? The EDTA replaces the indicator position. So it metal and indicator dissociate. The metal and EDTA forms stable complex, because EDTA is a hexadentate ligand, so it forms stable complex with metal. So if you add EDTA, the indicator is comes out and EDTA forms complex with these metal ions. So the metal and EDTA forms is strong complex. The metal and EDTA forms strong complex, and it releases free EBT indicator. It releases free EBT indicator. The color of free EBT indicator is blue. Okay, the free indicator is blue. See, the metal and indicator color is the wine red color. If we titrate it with EDTA, it forms stable complex with metal and EDTA complex. After further addition of EDTA, excess addition of EDTA, what happens? The release of free EBT indicator. The color indicates blue in color. This is the principal event. The color changes from wine red to blue in this case. See, this fact is used to estimate the hardness of water of sample. This fact means the color changes from wine red to blue. This is used for the estimation of hardness of water. See, the metal ions calcium and magnesium EBT indicator and forms less stable complex at pH 10. We have to maintain pH 9 to 10 by using the basic buffer, means ammonia buffer, NH4OH and NH4Cl composition to maintain pH 9 to 10. In this pH 9 to 10, the metal ions reacts with EBT indicator, means metal plus EBT forms metal EBT complex, that is unstable complex. The color of the complex is wine red color. The color of the complex is wine red color. What are the metals? Calcium and magnesium. Means the hardness, if you take hard water means the water contain calcium and magnesium salts. The calcium and magnesium salts present in water reacts with EBT indicator. It forms unstable complex, that is metal EBT indicator complex, that is unstable, and the color of the complex is wine red color. See, whenever we are adding EDTA solution to the wine red color solution, the metal ions forms more stable complex with EDTA. In previous slide, I have explained about metal EBT indicator complex, that is forms very unstable complex with EBT indicator. Okay, na? After then, whenever we add or whenever you titrate with EDTA solution, it forms metal and EDTA complex and releases EBT, because the metal EBT complex is unstable. So here it is forming metal EDTA strong complex and stable complex. The metal, when all the metal ions in the sample complex with EDTA, when all the metal ions complex with EDTA Further addition of ETA. After complexation, if you add further addition of ETA, it liberates the free indicator solution at pH 9 to 10. After completion of complexation with metal and EDTA complexation, if you add further EDTA, it releases EBT free. The EBT ligand is released. So the at pH 10, the color of the EBT indicator is blue. The color of the indicator at pH 10 is blue color, indicates the end point. Here the color changes from wine red to blue. The wine red color is due to the metal and EBT indicator complex, and the blue color indicates the after complexation the total EBT indicator releases, and the pH 10 the EBT indicator color is blue. Okay, see the metal EBT it reacts with EDTA, it forms metal EDTA complex and releases EBT. See, to estimate the hardness of water, it involved 4 steps. In the first step is the preparation of standard solution of magnesium sulfate and calcium carbonate. Actually, the EDTA is a secondary standard solution. To know the accurate concentration, we have to titrate it with a standard molarity containing solutions. Then we can calculate the accurate concentration of the EDTA. By using primary standard, we have to calculate the concentration of the secondary EDTA concentration. So for that purpose, we have to take the standard solutions, magnesium sulfate or calcium carbonate. We have to prepare standard solution by using magnesium sulfate and calcium carbonate. By using this primary standard, we have to calculate the concentration of the secondary standard EDTA concentration. Okay. For that purpose, we have to prepare the standard solution of magnesium sulfate or calcium carbonate. Suppose I want to prepare 0.01 molar magnesium sulfate solution. Okay, I want to prepare 0.01 magnesium sulfate solution. How we can prepare for 100 ml? The molarity formula is weight by molecular weight into 1000 by V in ml. The molarity I want to prepare 0.01 molar. So molarity is 0.01. You have to substitute. Weight, I don't know how much weight I have to add for 100 ml. And molecular weight of magnesium sulfate is, you have to substitute here. The molecular weight of magnesium sulfate is 246.48 grams and 1000. I want to prepare for 100 ml. So I have to substitute 100 ml here. If you cancel this, we will get weight 0.25 grams. The 0.25 grams, if you dissolved in 100 ml of water, 0.25 grams of magnesium sulfate, if you dissolved in 100 ml of water, that will produce 0.01 molar magnesium sulfate solution. The magnesium sulfate molarity we prepared 0.01 molar. Okay, this is the primary standard solution. In second step, I am going to find out the concentration of EDTA solution. I already explained the EDTA is a secondary standard solution. So by use the secondary standard EDTA concentration, we can calculate by using primary standard solution, that is magnesium sulfate or calcium carbonate. In this case, I am taking 0.01 molar solution of magnesium sulfate. By using this 0.01 molar magnesium sulfate, I want to calculate the concentration of secondary standard EDTA solution. See, for that, pipette out 20 ml of magnesium sulfate solution into the clean conical flask. For that, what you have to do? From this 0.01 molar magnesium sulfate, you have to take 20 ml. Okay, 20 ml you have to pipette out, take into the conical flask. 0.01 molar 20 ml magnesium sulfate I have taken into the beaker. Okay, then next what happened? Add 2 ml of buffer solution at 2 to 3 drops of EBT indicator. To this 20 ml magnesium sulfate, 0.01 molar magnesium sulfate solution, we have to add 2 to 3 ml buffer solution. What is the buffer? The buffer is ammonical buffer, that is basic buffer. The composition of ammonical buffer is NH4OH and NH4Cl. That buffer we have to add 2 to 3 ml to this solution, and we have to add 2 to 3 drops of EBT indicator. What is EBT? EBT nothing but aerochrome black tea indicator. Then the color of this solution, which one you get? Here the water, how much we are taking? Magnesium sulfate 20 ml, means here what ions there? Magnesium ions are there. Okay, for that we are adding 2 to 3 drops of pH 10 buffer, pH buffer or pH 9 to 10 buffer, that is basic buffer. Then we are adding 2 to 3 drops of EBT indicator. So what happens? The magnesium forms unstable complex with EBT indicator. The color of this solution is wine red color. The wine red color due to the magnesium and unstable EBT indicator. Magnesium EBT indicator unstable complex. The color of this is wine red color. Then take EDTA solution B8 after titrate with EDTA solution till wine red to color change to blue color. We are taking magnesium sulfate 20 ml 0.01 molar. Okay, now for that we have added EBT indicator and buffer solution. The color of this solution is wine red color. In B8, what we are taking? In B8 we are taking EDTA solution. Unknown concentration of EDTA solution you have to fill into this burette. Then titrate with EDTA and this magnesium EBT complex wine red color. Then one drop by drop if we are titrate with EDTA, then what happens? This wine red color changes to the blue color. Blue color due to the after complexation magnesium and EDTA stable complexation. If you further addition of EDTA, the free indicator releases from the solution. At pH 10, the EBT indicator color is blue. So the color changes completely is wine red to blue. That is the end point here. Okay. So note down the end point. Okay. Titrant and titrant values. See here. M1 is magnesium sulfate molarity. What is that one? 0.01 molar we have prepared. The volume of magnesium sulfate, how much you have taken? 20 ml you have taken in conical flask. M2, ETA molarity, we don't know. We have to find out this one. The V2 means volume of ETA consumed. We will get from burette. Okay, now after titration we will get from burette. This value is substituted. Then by using formula M1 V1 and M2 V2. The M1 is 0.01. Volume how much you have taken? 20. M2 means molarity of ETA we don't know. Okay. Then V2 is, what is V2? The volume of ETA consumed. We will get from the burette reading. So if you substitute these values, we will get the concentration of ETA. The secondary standard ETA concentration we will get from the primary standard magnesium sulfate solution. In this way, we will calculate the accurate concentration of ETA solution. Then see, here the color changes we can see. In burette, we have to take ETA solution. In conical flask, we have to take 20 ml magnesium sulfate solution and 2 to 3 ml of basic buffer we have to add and 2 to 3 drops of EBT indicator we have to add. The color of this solution is wine red color. The color of metal and indicator complex is unstable. The color is wine red color. After titration with ETA, the end point we will get from pale blue. Okay, this is the color changes we can observe in this standard ETA solution. Then step 3. In step 2, we have calculated the concentration of secondary standard ETA solution by using primary standard magnesium sulfate. In step 3, what we are going to do? What we are going to do is estimation of hard water. Estimation of hard water. Okay. In this step, we have to take tap water. Tap water 20 ml. Tap water contains both calcium and magnesium salts. The salts may be calcium carbonate, magnesium bicarbonate, and calcium sulfate. Other salts also involved. Means it contains both. This tap water contains both temporary hard water and permanent hardness of causing salts. So it contains, this tap water contains both temporary hardness causing salts and permanent hardness causing salts. Okay, we are taking this tap water 20 ml you have to take. Okay, 20 ml you have to take in conical flask. Okay, this water contains both calcium and magnesium salts. If we add EBT indicator and 2 to 3 drops of pH buffer 9 to 10. Okay, pH 9 to 10 buffer, that is ammonia buffer. It forms these salts. This water contains calcium and magnesium salts. This calcium and magnesium salts reacts with EBT indicator. It forms calcium magnesium EBT indicator complex, that is unstable. The color of this is wine red color. Okay, then in burette we have to take. In burette we have to take the standard ETA solution. The standard ETA solution means already we have calculated the concentration of ETA in previous step. Thus concentrated ETA solution we have to take in this burette, and we have to titrate these total hardness containing water with ETA solution. Okay, we will get color change from wine red to blue. Okay, note down the readings. See the calculation. In the estimation of hardness of water, what we have to do? First, we have to take tap water. Tap water contains both temporary hardness causing salts and permanent causing hardness salt. Okay. Then for that we have to add EBT indicator and the buffer solution. Then the color we will get wine red color. So then after we have to titrate with EDTA, already non-concentrated EDTA solution. Okay, it will form color changes wine red to blue. Okay, note down the readings. Then see, repeat the titration to get concrete values. Repeat the titration to get concrete values. See, let's take M3 means molarity of hard water. We don't know. We have to calculate the molarity of the hard water. Okay. Then V3, volume of hard water. How much we have taken? 20 ml we have taken in this case. Volume of hard water we have taken 20 ml. This contains both temporary hardness causing salts and permanent hardness causing salts. Then M2 nothing but ETA molarity. Already we have molarity we have obtained from the previous step. By using magnesium sulfate we have calculated the ETA concentration. Then V2 dash means volume of ETA consumed. We will get from burette readings. Then by using M3V3, M2V2 formula, we can calculate the molarity of hard water. The molarity of hard water means it contains total hardness, means the water contains both temporary hardness causing salt and permanent hardness causing salt. So we can call it as total hardness. In this step we will calculate the concentration of the total hardness. Okay, we will get total hardness of the water. Then total hardness we will get in molarity in this. Okay, we have to convert into the ppm. By using this formula we can convert the molarity into ppm. The molarity into 100 into 1000. If multiply this molarity into 100 and multiply with 1000, we will get the ppm in terms of ppms. Okay, by this way we can calculate the total hardness of water present in water by using ETA complex titration method. In this step we got the both temporary hardness and permanent hardness completely both together we got. That is called total hardness. The water contains both temporary causing salts and permanent hardness causing salts. So in this step we got the total hardness. First we will get in terms of molarity, then we have to convert into the ppm. Okay, that is the total hardness of water we will get in this step. See, in step 4 what we have to do? Calculate the permanent hardness of water. In this step 4 we have to calculate the permanent hardness of water. How we will get the permanent hardness of water? Take 150 ml of tap water. Okay, the tap water contains both the temporary hardness causing salts and permanent hardness causing salts. Okay, then heat this or boil this water. If you boil, what happens? If tap water contains temporary hardness causing salts like that calcium bicarbonate and magnesium bicarbonate. If boil this solution, the calcium bicarbonate converts into calcium carbonate and releases carbon dioxide, and magnesium bicarbonate on boiling it converts into magnesium carbonate, magnesium hydroxide and carbon dioxide releases. Okay, now these two are calcium carbonate and magnesium hydroxides are precipitate. So simple by filtration we can remove the temporary hardness. In that water, what is left? Only permanent hardness is left. Okay, after filtration we will get only permanent hardness of water. So after permanent hardness we will get, how we can calculate this permanent hardness of water? Same, by using ETA complex aromatic titration method. After boiling we have to filter it. After filter we take 20 ml. In this case 20 ml, what are the ions are there? Only calcium, magnesium salts, except calcium bicarbonates and magnesium bicarbonates. Other salts are present. Means temporary hardness is removed from that tap water. Only we are taking here permanent hardness water. Okay, this permanent hardness causing salts containing water we have to take 20 ml. Okay, in conical flask. And for this we have to add EBT indicator and pH buffer. The color we will get is wine red color. Okay, then similar way you have to titrate with known concentration of ETA solution. Then we can observe the color changes wine red to blue. Okay, note down the reading and repeat the titration to get concrete values. See the calculations now. See, M4 nothing but molarity of hard water. We don't know. We have to calculate the molarity of hard water. That is related to permanent hardness of water. Okay. The V4 nothing but volume of hard water. Volume of hard water, how much we have taken? 20 ml we have taken. Okay. The M2 is ETA of molarity. ETA molarity. The molarity of ETA is we obtained from the second step. Okay, na? We have calculated the concentration of ETA. Then V2 double dash nothing but volume of ETA consumed. We will get this value from burette readings. By using M1 V1 equal to M2 V2 formula, we can calculate the molarity of hard water. In this step we will get the permanent hardness. Why? Because already by boiling we have removed the temporary hardness. So in this case we will get the permanent hardness of water. So first in this case we get the permanent hardness of water in molarity terms. So we have to convert into ppm by using the multiplication with molarity into 100 and 1000. We will get converted into ppm. The molarity terms converted into ppm. Okay, in this way permanent hardness we got. In previous step we have calculated total hardness. Okay, now in this step by boiling we can remove the temporary hardness and we will only get the permanent hardness of water. Okay, so result C. How in second and third step what we have calculated total hardness of water. Okay, total hardness of water. And fourth step what we got permanent hardness of water. Okay, we know total hardness nothing but temporary hardness and permanent hardness. Okay, then third step we have calculated total hardness and fourth step we have calculated permanent hardness of water. Then how we can get the temporary hardness of water? Temporary hardness of water we will get from total hardness minus permanent hardness. In this way we can calculate the temporary hardness of water. So we from ETA complex metric titration method we can calculate the total hardness of water and permanent hardness of water. If we get both total hardness and permanent hardness of water, by subtracting permanent hardness from the total hardness, we will get the temporary hardness of water. So by using complex metric titration method, we can calculate the total hardness, temporary hardness and permanent hardness by color change wine red to blue. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.